All right, so from chapter 4, you just need to be able to work with exponential functions and equations, as well as logarithmic functions and equations. And so here we have a logarithmic equation, and it says to write the equation in its equivalent exponential form. So the way we do that, you remind yourself two important statements, and they are the base is on the bottom, and that helps you identify the base. This is the bottom number here. So the base is 7. And the log is the exponent. Here's the log. This is my is. The log is the exponent. So I'm pointing to the exponent. So remember those two statements. The base is on the bottom. The log is the exponent. That helps you identify the base and the exponent. Once you've done that, the 343 is what's left. So this tells you that 7 to the power of 3 equals 343. This is logarithmic form. This is exponential form. These two statements are saying the same thing in a different way. This is using a log, and this is using an exponential equation. So you're saying the same thing, but just in a different way. Whoops, got my equal sign. Okay, the base is on the bottom. That tells me I have 5 is my base. Okay, the log is the exponent. So 3 is my exponent. And what's left is the m. So this is exponential form. Again, the base is on the bottom. This time it's b. We don't know the base, but it's b. The log is the exponent. So 3 is my exponent. So b cubed equals 125. Now we're doing the reverse. We're writing it in logarithmic form. Okay? So the base is underneath the exponent. That's the 5. Obviously, the exponent is -4. So what's the other number is what's inside the log. So we have log. The base is on the bottom. So log base 5. And then we have our 1,625. And then you have the log is the exponent. The exponent is -4. So remember, your equal sign is always replacing the word is. So that's how you kind of sort it all out. You say the log is the exponent, and you just check to make sure everything's in the right place. Okay, so we're writing this in log form. Notice you don't really see an exponent there, but remember radicals are exponents, okay? So cube root just means having an exponent of 1/3, and your base is underneath the radical. So before you even begin, let me just do that for you. The cube root of 8 equals 2, okay? Before I begin, I want to change this radical into an exponent. Okay, And then the base is on the bottom, so this becomes log base 8. The log is the exponent. And what's left is my 2. I just dropped that into my log equation, okay? The log is the exponent. See how that works? Whoops. There we go. Okay. The log, the base is on the bottom, so that's base 5. The exponent is 2 because the log is the exponent, so I'm going to plug in the x. The log is the exponent. Now, obviously, for the test, you're going to have your calculator. So if it says evaluate the expression without using a calculator, there's no way I'm not going to go around the class and take away your calculator. But you're certainly welcome to use your calculator. But the reason why this problem is useful is because it helps you understand what logs are. Logs are exponents. And when the base is not shown here, as it is in this case, there's no base written, it's assumed to be 10. So this log is an exponent. What exponent on 10 will give you 1/10? Does anybody know? What exponent on 10 equals 1/10? Right, -1. So remember, logs are exponents. So when you're looking for a log, you're just looking for an exponent. Of course, you have to know what the base is. Now, another thing you should know about exponential functions and logs, they're inverses of each other. So this log here does not have a base, but it's understood to be 10. If the base is not written down there on the bottom, you just know that's a 10. And so we have log base 10, but it's combined with the exponential function base 10, and those are inverses of each other. So effectually, in effect, they cancel each other. So this is just 39.
So the base of log, and then
the base is 10, but we have an exponential function, 10 to the power of log, but the log and the exponential kind of are inverses of each other. They kind of cancel each other out. So you're left with 39. Of course, if you were to do this on your calculator, you get the same answer. But I'm just going through it without your calculator to help you understand what's going on. Here again, the natural log is base E, and here we have E as E to the raised to the power of the natural log. They cancel each other. So this is just going to be 3x squared. I don't think my colleagues would like me to say it that way, but for your purposes, when you're trying to get the answer, that's kind of how you would think of it. Okay, so another thing on the test that you're going to need to be able to do is expand and condense logarithmic expressions, and those are using the rules, okay? And remember, the log of a product is the sum of the logs. So here we have y cubed times x. So you're going to have the log of y, but the cube part, the exponent, is going to come out front, okay? You can take your exponents and move them out front, and then you take your product of your two input and then separate it by a sum. See how we're expanding? So we have y cubed and x are multiplied, so that translates to the sum of the logs. And then the exponent, the 3, because it's on the y, is going to come out in front of the log of y. Those are those 3 properties of logs that I went over in class.
What do you do with the base?
Oh, I forgot the base. I better put that in. So here's the base, b. And when you're expanding, the basis just stays the same. It doesn't change. So your bases are going to match, are going to match on the log there. Okay, that's better. Thank you. All right. Now, here we have no base. It's assumed to be 10, but they match. Now we're condensing. We're going the other direction. So we're condensing the logs. So since they match, we can do that. If they didn't match, if this had base 3 and this had some other base like 2, then they wouldn't match. We wouldn't be able to do it. But since they both have base 10, this 13, since it's out front there, is really an exponent. And since we're adding the 2 logs, that means we multiply inside the log function. So we have log, then we have y multiplied by z to the power of 13. This 1/3 just means we have a cube root of y. And then we're adding the log, so that means we multiply. So we have the cube root. Whoops, I forgot my log. Got to put that in. Natural log, cube y, and then times z.
What's the difference between ln and log?
Log by itself has base 10. The natural log has base e. So they're both log functions with different bases. E is a constant, like approximately equal to 2.7. So it's just a constant, just like the number 10 is. Yeah. It's commonly used log, so that's why they shorten it as natural log. All right. Here where we are asked to evaluate this log, notice the base is 0.6 and you're taking the log of 18. I'm going to write this down on my paper and show you how to do this problem. Okay, there is a problem like this on the test, so make sure you know how to use the change of base formula. Just standing alone, you can't calculate that with your calculator because your calculator doesn't have log base 0.6. Your calculator has only 2 logarithms stored in it, and that would be log base 10, that's the common log, and the natural log, which is log base e. This log has base 0.6, so I have to use what we call the change of base formula. Okay, so let me explain what the change of base formula is. So if you have a log of base b and you want to evaluate it at some constant a, you just take the common log of a and divide it by the common log of b, or if you want to, you can do the natural log of a divided by the natural log of b. Really any base, but because your calculator has these 2 stored in it, you would want to either use this formula or this formula. And notice the base is on the bottom. That's how I memorize this formula. I always remember the base is on the bottom and the numerator is just the other number. Okay, so here's the base. That's going to be on the bottom. So you take log of 0.6 and then your other number is going to be on the top. So you take log of 18. And now you can use your calculator because you're using the common log here. So going to the calculator, you take the log of 18, close the parentheses. Don't forget to close the parentheses because then if you don't, you're going to be dividing 18, not log of 18. So then divided by the log of 0.6. So that's negative 0.658. negative 5.658. Okay. Now, if I do this using the natural log, I'm going to get the same answer. The natural log of 18 divided by the natural log of 0.6. See, I got the same answer. So it works. It doesn't matter if you use the natural log or the log, but you have to know the change of base formula. And there's at least one problem like this. I think there is one problem on the test like this. I think it's worth like 6 or 7 points. So out of 175. So, you know, just little details like that. Just know this formula. All right. So going back to this problem. Oh, it said to 4 decimal places. Let me see what 4 decimal places would be. So to 4 decimal places, it's going to be 0.6582, negative 5.6582. Whoops. Right there. Okay, you should be able to solve exponential equations. The trick is to take the log of both sides, either the natural log or the common log. But in this case, since we have base 10, you just want to go ahead and do the common log. So we take the log base 10 of x equals log of 4.82. I just took the log of both sides. And you see we get, this is base 10, right? It's a common log. So this effectively cancels, so it's just x. Okay, now what if I took the natural log of both sides? So this is using the log of both sides. What if I decided to take the natural log of both sides? So if I take the natural log of both sides, I get, these don't cancel now because these bases don't match, right? But with the properties of logs, I can bring the x out front because it's the exponent. So it becomes x natural log of 10 equals the natural log of 4.82. And so then dividing both sides by natural log of 10, I get x equals the natural log of 4.82 divided by the natural log of 10. Notice this is just the change of base formula, right? The base is 10, the base is on the bottom, and so these two are identical. These are the same answers, but I used 2 different methods. Here I used the common log, and this just canceled to get x equals log base 10 of 4.82. Here I use the natural log, and here I have the change of base formula, right? Which is equal to this. So you're going to get the same answer.
Why wouldn't you do log base on the very first part? Why wouldn't you do log base 10?
I did.
2, 4.
I did log base 10. I just didn't write it because it's a common log. You don't have to write the base for the common log.
Okay.
Yep. So it's going to be 0.6830. All right, here we have an exponential function, and it says find out how long it takes a $3,400 investment to double if it is invested at 8% compounded monthly round to the nearest tenth of a year, and use this formula. So this formula, there are two formulas. There's A, let me just write this down. There's two formulas. There's this one, A equals P times 1 plus R over N to the NT. This is for a finite number of compoundings. Okay, finite number of compoundings, and that finite number is N. All right, that's this formula. Now, if you have A equals PE to the RT, this is a continuous compounding. So you need to know which formula to use given your situation. In this particular example, we are told that it's compounded monthly. And I should say finite number of compoundings per year. So if it's compounded monthly, then N equals 12. So I'm not going to use this formula. I'm going to use the one with the N in it, because this is the finite number, N equals 12. If it's continuous compounding, that's when you use this formula. So you got to pick the right formula. So we are going to pick this one here, and we just plug in our information. P is 3,400. That's the investment. And then you take your interest rate, 8% divided by number of compoundings. And I forget what it said on how many years. Hold on, let me go back. It said, oh, we don't know the number of years. And notice here it says, we want to know when is the investment going to double. Okay, so we're solving for T, right? T is our answer that we're looking for. So we don't know T. We're solving for T, but notice here investment is doubling. So if you go back to our problem, our investment is 3,400. If you want it to double, A has to equal 6,800, right? So you plug in 6,800 equals 3,400, 1 plus 0.08, 12 to the power of 12t. This is the equation we have to solve for t. Okay, so how do we do that? Well, first off, you want to isolate your exponential piece. So this is the exponential piece. So I'm going to divide both sides by 3,400. And that gives me, first of all, I'm going to calculate this, 0.08 divided by 12. Let me go to my calculator. And then we're adding 1 to that. I probably should just leave it in that format because I don't want to round it. Never mind. Sorry about that. Okay, so I'm just going to leave it like this. But when I divide 6,800 by 3,400, obviously that's going to be 2 because we're doubling it. And then this is going to be 1 plus 0.08 over 12. I'm going to calculate that at the very end to the 12t. Now, how am I going to get that variable out of the exponent? Well, you're going to take the natural log of both sides. So you get the natural log on the left, that's the natural log of 2, is equal to the natural log of the 1 plus 0.08, 12 over 12t. Now, by taking the natural log here, this 12t, I can bring it out front. I'm running out of room, so I'm going to go on to the next page, okay? Let me copy this. See how that works? This is the t, 12 times t. That was in the exponent, but because I'm taking the natural log and by the properties of exponent, I can bring that out front. Now, all I have to do is divide both sides by 12 natural log of 1 plus 0.08 over 12. And dividing that, this becomes t now, these cancel, and t is by itself. Like that. And now I plug it into my calculator. So I take the natural log of 2 divided by the quantity 12 times the natural log, natural log of 1 plus 0.08 divided by 12, close my parentheses, 8.69. So C is the correct answer. 8.69 rounds up to 8.7 years. Okay? Here we have a formula. It says it models the population of a particular city in thousands. T years after 1998. When will the population of the city reach 282,000? So this is basically the same problem as the last one. We're looking for T. So we have 282,000 hold on. Let me fix that. I'm not going to write out 200. I'm just going to write 282 because the model is in thousands equals 249 e to the 0.025t. So we're going to solve this equation. So I want to get the exponential piece by itself. So I'm going to divide by 249 on both sides. Okay, and then that gives me 282 over 249 is equal to e to the 0.025t. Now, if I take the natural log of both sides, I'll be able to effectually cancel out this. So this becomes the natural log of 282 over 249 equals the natural log of e to the 0.025t. These are inverses of each other, so they cancel. So this becomes 0.025t equals the natural log of 282 over 249. So dividing both sides by 0.025 will give me my t. All right. So t is equal to this. You'll want to practice using your calculator, the one you're bringing to the test. So we take the natural log of 282 divided by 249, because there are a lot of calculations, you know, maybe not a whole lot. Most of the test, I think, is just concepts. But if you're solving an exponential equation, there might be one or two problems where you have to do that. So so it looks like 5 years and 1998 is the starting year. So 5 years after 1998 is 2003. Okay, what I'd like to do now that I've finished up going through example problems, I just want to kind of go over the list that I gave you. I sent it in an email. I'll probably send it again in another email in case you lost it. But I got to find that page. I don't know. Here it is. So I emailed this to you. And I'm going to email it again along with the links to the uploaded videos. One from my 9:30 class and then the one that I'm recording just right now. So you have that to kind of go through. This list just kind of narrows down what's on the test. And I forgot to write multiplicity of zeros. You need to know that and understand what it means and how it affects the graph, okay? So first of all, you need to know how to identify a polynomial. So I think there were some problems in the homework like this. Basically, a polynomial looks like P of x equals 3x to the 5th minus 2x squared plus 1, something like that, right? The highest power on x is the degree. So be careful if it's something like this, where you have x squared minus x to the 7th, okay, even though this is in front, this is not written in the proper order. So the degree is the highest power. So 7 is the degree, okay? Then whatever coefficient is in front of that term, so here, this leading coefficient is going to be -1, right? Because this is the term, the leading term right here. Even though it's not in front, it's the leading term. So here, the degree is 5, and then your leading term is 3. Or leading coefficient is 3. Okay. Let's see. Let's suppose you have something like now with the degree, so here we have degree 4 and leading coefficient -4. And then let's say we have s of x equal 2x squared, okay? So these are examples of polynomials. One thing that, if you have a quotient, okay? So if you have a function like f of x equals 3x squared minus 2x plus 1 divided by 2x minus 5. This, even though the numerator is a polynomial and the denominator is a polynomial, the quotient is a rational function. So this function is not a polynomial. And also you cannot have like radicals over with the x under the radicals. So this square root of 2 times x, that's a polynomial, but square root of 2x is not a polynomial, okay, because the x is under the radical. So you can't have exponents. Your exponents have to be positive, and they also can't be fractions. So they have to be positive integers, or whole numbers. If you have a constant, your x is like x to the 0, but we don't write x to the 0 is 1, so we don't write it. But so just be able to identify polynomials, be able to find the degree, find the leading coefficient, and then use that to determine the end behavior. So let's look at these now. I intentionally picked 4 to show you that each of these have different end behavior. What I mean by end behavior is what does the graph look like on the ends of the function? So if your degree is odd, like these first 2 examples, then on the left, it's either going to rise or fall, and it's going to be the opposite of what's happening on the right, okay? So let me get a different color marker so I can highlight this. Okay, so I'm talking about end behavior now. Okay, so if the degree is odd, this one is going to fall to the left and rise to the right. Okay, in other words, the graph is the graph is going to look like this on either end. Okay, if you have odd degree and positive leading coefficient. If you have odd degree and negative leading coefficient, then it's going to rise to the right. I'm sorry, to the left. And fall to the right. So when the degree is odd, it's going to be opposite. Here it's fall and rise, rise and fall. So this one's going to be like this and like this. The graph is. Then something happens in the middle, but we're talking about the ends of the graph. Now, when it's even and it's negative, both sides are going to go down. So you're going to fall to the left and right. And here it's even with a positive, so it's going to rise to the left and right. Okay? So that's called end behavior, so know how to interpret that. I want to talk about finding x-intercepts, okay, and y-intercepts. You need to be able to find x and y-intercepts for a polynomial and for a rational function, okay? So, all right, just find x-intercepts, you set your function equal to 0. So if you have a polynomial, so let's say f of x equals x squared minus 4, okay? To find the x-intercepts, you set your function equal to 0, and then you solve for x. So this means that if I solve for x, I get that x is equal to -2 or x is equal to 2. By setting the factors each equal to 0, I get these two solutions. So -2, 0 and 2, 0 are x-intercepts. The x-intercepts correspond to 0. So this means that -2 and 2 are real zeros. So these go hand in hand. X-intercepts are points, and then the x values for the x-intercepts are your real zeros, okay? Now, if your function is rational, so if you have something like x plus 2 over x minus 3, then to find the x-intercepts, you set your function equal to 0. But in order for a rational function to equal 0, that means your numerator is 0. So you're setting your numerator equal to 0. So x plus 2 equals 0, x equals -2. That means that -2, 0 is the x-intercept. All right. Now, to find the y-intercept, I'm going to change colors here.
3 wouldn't be an x-intercept.
Correct. X equals 3 is a vertical asymptote. Can't have 0 in the denominator, right? So you're going to have a vertical asymptote. Now, oh, my hand's kind of cramping up here. To find the y-intercepts, set x equal to 0 and calculate and evaluate. So in other words, if you have f of x equal to x squared minus 4, f of 0 equals 0 squared minus 4, which is -4, which means that 0, -4 is the y-intercept. And because it's a function, there's always only one y-intercept. You can have many x-intercepts, but you can only have one y-intercept. So for example, if g of x is x plus 2 over x minus 3, g of 0 equals 0 plus 2 over 0 minus 3, which is minus 2/3, which means that 0, -2/3 is the y-intercept. Okay. Now, if you want to, so looking at our list here, I've been going down the list. I talked about how to identify polynomial, find the degree. In the earlier class, I did this multiplicity thing, so take a look at that video. The leading coefficient test, I went over that in that class as well. And understand the relationship between zeros, factors, and x-intercepts. So let me talk about that for a minute. Okay. Basically, a 0 is the x value of an x-intercept. And another word for zero is root. So I'm not talking about the number zero, I'm talking about a root or a zero. It's the x coordinate of an x-intercept. So example, 2, 0 and negative 3, 0 are x-intercepts. Then 2 and negative 3 are zeros of the function. Okay. So example, here we have a function, okay? If these are factors, so 3 can't equal 0, right? But if I want to find the zeros of this function, the zeros are the same as finding the x-intercept. So I set y equal f of x equal to 0. So in doing so, if 3x cubed times x minus 1 squared times x plus 1 to the 5th equals 0, that just means that either x is equal to 0, x is equal to 1, x equals to minus 1. These are the zeros.
So you just plug in 0 everywhere you see x.
What's that?
Plug in 0 everywhere you see x.
Well, this factor tells me that if I plug in a 0 here and I multiply these other things by that 0, the whole thing is 0. Or if I plug in 1, 1 minus 1 is 0, so everything will be 0. Or if I plug in negative 1, I'll get 0. So that means these values are the zeros. And 0 has multiplicity 3. 1 has multiplicity 2, and then negative 1 has multiplicity 5. Now, if the multiplicity is odd, so if you have odd multiplicity, then here, if this is the x-axis and here's your 0, it crosses the x-axis, okay? But if you have even multiplicity, it touches and bounces back, okay? So if it's odd, it crosses, and if it's even, it touches and bounces back. So you'll see in your homework or on the review, you'll see questions about that. Okay, so pay attention to those because there are 4 questions on this. And I went through this. I'm not going to go through it again because I'm not going to have enough time. But I went through this with my last class. So make sure you look at that video because I do several examples. And there are 20 points of the test covers just this one concept. So don't overlook it. It's really easy to learn. And there were examples in the homework and there are examples in the review. So make sure you know how to do those. It also involves finding holes, okay, in your function. So there are vertical asymptotes. Actually, this is a polynomial. I'm talking about rational functions, but there's one question on multiplicity like this for a polynomial. Check out that other video where it talks about rational functions. Okay. Let's see what else. I want to make sure I cover everything. on my list. So with rational functions, in my last class, I talked about how to find horizontal asymptotes and vertical asymptotes. To find vertical asymptotes, you set the denominator equal to 0 and solve. Okay. And then to find horizontal asymptotes, you look at the degree. So make sure you check out that video if you don't know how to do that. I also talked about finding the location of a hole, and I solved rational equations and inequalities as well as polynomial equations and inequalities. And then I went through chapter 4 with you to start out. Okay, so I went through these. Here, when you're finding the domain of a logarithmic function, you set the argument, that's what's inside the log, greater than 0. So let me go through an example for that, okay? Okay. So here we have a function. It's a logarithmic function, so log base 2 of x squared minus 1. The base is irrelevant to this problem because we're just looking for the domain. And any log function, you cannot put in a negative and you cannot put in 0. So in other words, this is your input right here, okay? That's your input into the log. Your input must be greater than 0. This is a polynomial inequality. So to solve this, you have to find the zeros. That's the first step. So if I set x squared minus 1 equal to 0 and solve it, I get x squared is equal to 1, x equals plus or minus 1. So the zeros are 1, 1, and negative 1, and I plot those on my number line, which is the x-axis. And then I have to test the regions, okay, to check and see which ones make this true. So if I plug negative 2, I'm going to pick negative 2, just randomly pick it, but it has to be in this interval. Plug it in. Negative 2 squared is 4. 4 minus 1. Is 3 greater than 0? Yes. So it's true. If I plug in 0, 0 squared minus 1, that's negative 1. Is negative 1 greater than 0? No, that's false. Then here I plug in 3, let's say. 3 squared is 9 minus 1, that's 8. Is that greater than 0? Yes, that's true. So the solution is everything that makes the inequality true, and that would be this interval, so it'd be from minus infinity to negative 1. Of course, I don't want to include negative 1 because I'm talking about strictly greater than 0, and then 1 to infinity. And so this is my solution set. In other words, this is the domain. So the domain is equal to the set of all x. Actually, I'll just say this is interval notation. This is just d equals, that's your domain in interval notation. I was about to put it in set builder notation, but that's more complicated, so I'll just leave it like that. Okay? So make sure you know how to solve these inequalities. There's one polynomial inequality and one rational inequality on the test. And are there any questions that you want me to, that you have about this list of things on the test? Anything you want me to do from the homework or quizzes or Any problems that you got stuck on that you want me to go over? So basically, I'm going to post that video today. I covered this first part. I went through a lot of example problems in my first class, and then I started out doing it, this bottom part with you all. So between the two videos, you should have a complete review. Of course, you should have watched the videos that I recorded. So there may be some things in there that would be helpful for you to go over. So I don't know if you've watched those videos, but if you haven't, it'd probably be a good idea to just go over all that stuff.
Are you going to post that on Colgate?
Those are posted in YouTube.
I know, but there's like the.
Oh, I'm going to post these in YouTube. So I'll send you an email with the link, and also I'll send you it in case you don't have, I'll send you a copy of this as well. Okay. I probably will post it when I get home today, so you'll definitely have it at some time this evening. So, okay, any questions that you want to go over? I think that covers it pretty well. Email me if you have any questions, so make sure you know which group you're in. Group 1 will start on Thursday taking the test, and then the following week will be group 2 and group 3. Okay. All right, thank you.